to be here. If the heats of formation for both the reactants and products in a chemical reaction are known, then delta H for the reaction may be calculated. In this video, I will explain how to calculate the delta H of a reaction using the direct method. Consider the following example where ethene reacts with oxygen gas to produce carbon dioxide and water. The molar ratio is 1 to 3 to 2 to 2. The heats of formation for both the reactants and products may be found on a table. The heat of formation of carbon dioxide gas is found to be a negative 393.5 kilojoules per mole. The heat of formation of liquid water is found to be a negative 285.8 kilojoules per mole. When using a table of heats of formation, be sure to select the correct state of either the reactant or the product. For example, in this case, the heat of formation of liquid water is a negative 285.8 kilojoules per mole. This is not the same value that's listed for water vapor. The heat of formation of any element will always be 0.0 kilojoules per mole. And in this case, the heat of formation of ethene is listed at a positive 52.3 kilojoules per mole. Now simply use the delta H formula, where delta H is equal to the sum of the heats of formation of the products minus the sum of the heats of formation of the reactants. In this case, the products are carbon dioxide and water, and the reactants are ethane and oxygen gas. There are 2 moles of carbon dioxide on the product side and 2 moles of liquid water. From the table, the heat of formation of 1 mole of carbon dioxide gas is a negative 393.5 kilojoules. Since 2 moles are being produced, simply multiply this value by 2. Likewise, multiply the heat of formation of the liquid water by 2, because in the reaction, 2 moles of liquid water were produced. From that, subtract the heats of formation of the reactants, where the heat of formation of ethene was found to be a positive 52.3. Since the coefficient associated with ethane in the balancing equation is 1, then assume that a 1 has been written in front of this expression. The heat of formation of any element is 0. So although there are 3 moles of oxygen gas consumed during the reaction, the heat of formation is written simply as 0. 2 times negative 393.5 plus 2 times negative 285.8 minus a positive 52.3 plus 3 times 0 will yield a delta H for this reaction to be negative 1,411 kilojoules. Now for another example where hydrogen sulfide reacts with oxygen gas to produce water and sulfur dioxide. The molar ratio in the balanced equation is 2:3 to 2. The values for the heats of formation, which are taken from a table, are listed as follows, where the formation of H2S is a negative 20.15 kilojoules per mole. And of course, the formation of oxygen or any other element is always going to be 0.0 kilojoules per mole. The formation of liquid water is listed at a negative 285.8 kilojoules per mole. And the formation of sulfur dioxide gas is listed at a negative 296.1 kilojoules per mole. Now the delta H for the reaction may be easily calculated, where the sum of the heats of formation of the reactants are subtracted from the sum of the heats of formation of the products. 2 times a negative 20.15 plus 3 times 0 will be subtracted from 2 times a negative 285.8 plus 2 times negative 296.1. So, subtracting the sum of the heats of formation of the reactants from the sum of the heats of formation of the products will yield a final delta H for this reaction to be a negative 1,124 kilojoules.
CoastToCoastMixtape.com